Good morning, students. Good morning, friends. I am Jagan Babu, Assistant Professor, RMD Engineering College, and in Digital Signal Processing in this semester. Let we have a small discussion on problem in unit number 4, finite word length. The problem based on steady state error with the range is given. The most of the problem, the range will not given, problem will be easy. In this problem, the range is given directly. Yeah, we have the question now. A system is characterized by difference equation y of n is equal to 0.75 y of n minus 1 plus 5 x of n. The input signal x of n has a range minus 6 volt to plus 6 volt. Represent by 8 bit. Find the quantization step size, variance of error signal, variance of the quantization noise at the output. Solution. Y of n is equal to given y of n is equal to 0.75 y of n minus 1 plus 5 x of n. That is a given question. Once we move to the problem, convert into the z transform in term of z. So apply the z transform on both the sides. The y of n become y of z is equal to 0.75. How to write y of n minus 1? Anything power minus 1, it becomes z inverse y of z. Plus anything power minus 2, it becomes z power minus 2 y of z. Plus 5x of z. Therefore, y of z is equal to, take this y of z to this side. One y of z with another y of z. Take this y of z to this side. So y of z is common. So 1 minus 0.75 z inverse, which is equal to 5 into x of z. Therefore, find transfer function h of z. In some problem, they directly ask find transfer function, or else you need to find transfer function. H of z is equal to y by x, which is equal to 5 divided by 1 minus 0.75 z inverse. So can I write like this? 5z by z minus 0.75? It is also correct. Okay. See the question number 1. Represent by 8 bit, find the quantization step size. So quantization step size, the symbol is Q. The formula for quantization step size is dynamic range divided by total number of levels. Dynamic range divided by total number of levels. Dynamic range, nothing but the range is given in term of volt, minus 6 volt to plus 6 volt. That means total 12 volt, it given like a ground, minus 6 volt to plus 6 volt. Therefore minus 6 plus 6, so 6 minus of minus 6 become 12 divided by 2 power b. B is given as 8 bit, so 2 power 8. Therefore the Q value 12 by 2 power 8 is equal to 0.046875. Question number 2. Find the variance of error signal. The formula is sigma E square. Sigma represents variance, E represents error. Therefore sigma E square equal to Q square by 12, which is equal to Q is nothing but 0.046875 the whole square divided by 12. You get the answer sigma E square equal to 1.831 to 10 to the power of minus 4. So part 1 quantization step size over Q. Part 2 variance sigma E square over. Come to the part 3. Variance of error signal, that is quantization noise at the output. So formula, variance of the quantization noise at the output, sigma epsilon square. It becomes sigma epsilon square equal to sigma E square by 2 pi j integral h of z inverse dz in term of integration. But we are not going for any closed integration formula. We have another formula using residue method. So sigma E square residue method of h of z inverse z minus 4. So for the h of z, we are replace here h of z here. 5z by z minus 0.75. Into h of z inverse, just put wherever z inverse. Therefore 5z inverse by z inverse minus 0.75 into z inverse. What is my pole, the denominator, which is nothing but 0.75. So z minus 0.75. Now we need to calculate, which is equal to sigma E square residue of, so 5 into 5 it becomes 25. See this last step here. Now here it is 5, here it is 5. So 5 into 5 it becomes 25. So 25 sigma E square residue z minus 0.75 cancelled and get the answer z inverse by 0.75. So 25 sigma E square, which is equal to, substitute wherever z is equal to 0.75 z inverse by 0.75 z minus 0.75. Now 25 into, what is my sigma E square answer? Sigma E square answer is calculated here as 1.831 10 to the power of minus 4. Now substitute here which is equal to 25 into 1.831 10 to the power of minus 4 into the calculation part of the bracket is 2.2857. Therefore, the final answer of the variance of the noise error sigma epsilon square equal to 0.01046. Sometime the problem will be asked to draw in the direct form structure or cascade structure. Right? Thank you, students. Any doubt in this problem? Very important 30-mark problem. Thank you, students. Thank you to all.